Hey guys, welcome. If you're new to this channel, I'll quickly tell you what we do differently. So I will not just explain you the solution to some problem, but I will also let you know what are the data structures that we are supposed to use to this question and how to even build this intuition behind understanding which algorithm we are using and why we are using. So we kind of dive a little bit deeper. Most of the times, I'm guessing, see, if this is your first LeetCode question you're solving and you were not able to solve this, it's completely fine. More often than not, this tag is highly misleading, and there will be a lot of times you would find easy questions that are kind of very difficult to solve at the first time. So please don't feel disheartened if you weren't able to solve. But if you're directly watching this solution without even trying, I would recommend please solve it first and then come and watch this video. Let's quickly discuss. So before even we actually read this, what I like to do is actually just read here and look what the inputs are and what is the expected output. So we are getting a list of integers. You have another variable target that's coming as an input, and the output that you are supposed to give is actually again a list of integers. Okay, so we know that we're getting a list and an integer like this, and you have to return a list. Cool, this is clear. So it's kind of like two sum where like roughly speaking, you have to find two numbers in this list of numbers that add up to this target. So when it comes to understanding this problem, I feel it's fairly straightforward, and they haven't made it tricky to first understand it. However, like the implementation can be very, very tricky, especially for the most efficient solution. So let's quickly discuss a brute force solution. So for that, I'll bring my iPad on the screen. Okay, let's go. So here, I'll try to take the same example that was given in the question. So let me, it's 2, 7, 11, 15, and the target is 9. Okay. Yeah. So this is our nums array, and our target is going to be 9. So what will be the most intuitive way to solve this? I like to kind of add more elements for your imagination, and maybe that kind of gives you more deeper understanding. So imagine that you are standing and you are holding this first number. Let me take a different color. So you're holding this number in your left hand. So the one that is highlighted is something that you already have in your left hand. And then you are actually going to consider these numbers one by one. So you'll see, like, is 2 plus 7 equal to target? Oh damn, yes. So you've already solved the question in like just one pass. But let's modify this a little bit. Let's say you had 8 here and 7 was here. So now let's just like do a very quick dry run and a walkthrough of the brute force. You have 2 in your left hand. 2 is something that you are holding in your left hand, and you keep checking each and every pair in the nums array. So you'll check 2 and 8. You know the sum is kind of 10, which is greater than target. So you're like, no, this is not what I'm looking for. You move ahead from 8 to 11. Now you check 2 and 11. It's not 9. You move ahead. You go to 15. You check 2 and 15. It's not. Then finally you check 2 and 7. It's actually equal to the target 9. And then you're like, yeah, found a pair. Now in this case, this was fine because you had 2 here. Let's try to change this a little bit. What if I tell you we had 9 over here? Oh, that'll be very easy. But yeah, actually, yeah, no. Let's kind of not make it complicated. Let's assume you have 4 here, and 2 is here and 7 is here. So imagine how many wasteful computations you're going to do. Like, you're going to first consider this, and then you're going to check every pair. 4, 8, 4, 11, this. After this is over, you're going to move ahead. You're going to check this, and then you're going to check each and every pair. And imagine how long and how much time it will take you to even find the right pair. Is there a better way? And to put like things in perspective of complexities, you have O of n square. but the space complexity is constant. So because since you're not creating anything new, it's kind of like just using the input that you have gotten. You're not doing anything additionally that kind of linearly scales with the increasing size of the input. Then the space complexity is O of 1, which is constant, but the time complexity is O of n square. Now this is something that we have, the reason why we have discussed this is to just benchmark few things, so that we know that, hey, this is like something that we can do as a, brute force approach, but can we do better is the question. So the answer is yes, we can do better. And to even, get into the optimized solution, I would actually like to give you a mathematical proof for this. So we are going to use this concept of is duplicate. I guess is duplicate is one of the question that we have solved already on the channel. It's going to use kind of like a similar framework that we used while solving this. It's also an easy problem, but like it kind of uses the same idea here. So let's break down the question and make things very easier for us. You know that you have to find a number A and another number B that kind of sums up to your desired target. So here you look at the left hand side of the equation. You know that you need to have at least two numbers. You need to be aware of two numbers to make a choice that yes, this equals to the target, or no, this doesn't equal to the target. So just by looking at this, you know that you need to have more data to, make a conclusive answer, or to just say and to conclude that, hey, with utmost confidence. So like in terms of, like for if you write for n in nums in Python, you know that you only have access to one of the element. You may argue that if I have like an index idx, I can access elements before the idx and elements after it by writing idx index plus some value n, and you might write some idx minus value y and access those. But the point here is that you still have only one anchor. So the anchor, or like the baseline or the benchmarking, is done with respect to idx. So can we rearrange this equation to fit our use? So what I would like to tell you is, like, let's say you have a list of a list of numbers like 2, 8, 10, anything. And I'm just telling you can only see this part. Like, you have only seen this part and you don't know what comes here. So you are completely unaware. You don't know. There's like, you don't know. There's a curtain, let's say. You don't know what's coming after it. But you have this number in hand. So if you had to just make a choice based on what you know, how can you do so? It's just by rearranging this equation. But now let's talk in terms of what you would want if it was Christmas and you were to ask for a present, and the value for A is actually 2. What will you ask for the value of B if your target is, let's say, if you wanted to have a target that is 7? Yeah, I mean, you will always wish for the value of B to equal to 5 because you want your target to be 7. In other words, can we write this in terms of mathematical equation? So, you have the value of A. Can you write the value of B? Yeah. So, this is known. This is unknown. This guy is unknown. You also know the target. Yeah. You also know the target. You also know your target is on the right hand side. Can you kind of create an equation or some relationship to find the value of B? Yes, right? Like, the way you can like simply write is by take A to the right hand side. So you can write B equals to target minus A. And in other words, if you feel fancy, you can call this like complement. Like, you can call it as A complement. And A plus A complement is like the universal set, which actually is equal to the target. So the reason I'm actually spending a lot of time here is to build a very, very strong intuition behind why and how we are doing these things. So if you were to know this is number 2, the only thing that you would always wish for is like a complement or a number that is target minus the current number that you know. So if you were to know that yes, this number is present in the list, you have already found an answer. And like to put things in like much more easier terms and more Pythonic way, we actually like to call n as our current number. So n is some like you have list of numbers, let's say 10, 2, 500. So n actually points to one of this integer in our list of integers. So if you were to calculate, let's say the complement of n. So just remember this formula in mind. So n plus n complement is equals to target. This is what we are finding. And now, as discussed previously, all that is of our interest is this complement, or this number target minus n. So can you actually, think of a way to actually keep track of these things? You need to have like a set or like a hash map. And the reason why we are adding hash map is because if you go to the question here, like you look here, like they are expecting us to send indices of these numbers and they don't want the numbers. So if the target is 9, the return should not be 2 and 7, but it should be the index value of 2 and index value of 7. And that's the reason why instead of writing set where you would only store the numbers, what we are doing is creating a hash map, or like we create a dictionary where the number is going to be the key and the respective index is going to be the value. So this is how our hash map will grow. And is that number like something familiar to you? Yeah, this is exactly this complement. So what we are doing is we are actually creating, let's say, n complement. N complement is actually the name of the dictionary that we are going to grow. And this will keep track of the complements that you've seen so far. So let's say in the future you were to find some value n, and you know that n complement is already there in your this n complement dictionary. You have found your target. And the way in which you would return is, because you are enumerating or you are iterating, you currently have the index value of this number. Like this is something that you already have in the current ongoing iteration. N complement is something that you can just look up here. It will go search for this number in this dictionary like this, and you return the value associated to that key, which is the index or the respective index at which the number is sitting. So this was kind of like the mathematical proof to even understand and to build a very strong and a robust foundation in understanding the two sum. So to quickly summarize, what we want to do is the question had asked us to find, I'll take a different color so that's easier. So the question had asked us to find a plus b. That kind of sums up to target. We were like, hey, in Python or in any other language, if we were to go with a for loop, we only have the data for the one number, or we can only have enough information, or we can benchmark with respect to one number. So for that, we were like, hey, I am actually having a or n in my hand. But I can actually look up and create another data structure like a dictionary to keep track of target minus b. I can look it up in some another dictionary and compare if this plus something that I've already seen as a complement adds up to target. And in this pursuit, we realize that yes, we can actually have a very, very better solution that can not take O of n square, but can linearly solve. So this is something that you were going to see in case of brute force, where you write a for loop and another for loop under it. This is a single pass. You just iterate through all the numbers in one go. And let's say you were to find an answer very early in the progression. You have also this benefit of early exit in this case. So I hope like you've understood and you've built a very strong intuition here. So let's quickly go back to the coding and write up this solution ourselves. I'm going to make a little bit of space. I'm going to shift this to the right. Okay. So as discussed, we know we are actually creating a set or a hash map to store the n complement value. So we have initialized an empty dictionary, and what is a complement? It's basically n plus n complement should equal to target. What is your n complement? Your n complement is going to be target minus n. And this is something that you'll keep looking for every number. One small quick tip that I would like to tell is, a lot of people will write for I in range length of numbers. So there is nothing wrong in writing code like this. But since you are writing code in Python, how about we make the best use of all the functions that we know here and make use of the enumerate method. So for index comma n in enumerate nums. And just to put more, maybe just in order to convince you that this is better, this is actually much more faster and efficient in Python, because in these specific scenarios where you have to keep track of the index as well as the number, this is very, very faster compared to writing code like this. So we'll make use of this syntax. And this, if this is new to you, just feel free to, check out some documentation online, play around this, print in a Jupyter notebook, and learn in a visual way. And this will probably be like second nature to you. So don't worry about this if this is kind of new, but we'll make use of this. We know already what our goal is. We have to check, is the current number plus the target equal to, plus the complement equal to the target. You have this number in your hand. What you have to check is if target minus n, if this n complement is in our n complement. So I'll simply copy paste this from here. If this is the case, you found your answer. So what to do is return n complement is going to be the hash map. You have to go fetch this value, which is going to be the key, and the value for this key is going to be the index, and then you have to return the current index, the IDX that we are going. So this is the case when you have found an answer. So this is when you have found an answer. But what if you have not found an answer? And let's say this target minus n is not in n complement. And in fact, the first iteration will be like false because n complement is empty and the first number is not there. So what you do is simply push this thing as an n complement. So you put this current number along with this index into this n complement. And you might have this question like, hey, how is this an n complement? This is an n complement because you can always have a number as a complement of itself. For example, if you look in this case, like 3 and 3, you might argue saying that, hey, how can 3 and 3 be, allowed to be a target, because the question has told us that you can only have a unique pair of elements to be the answer. So the simple explanation is that they have different indices. It ends there. There is only one valid answer. This is true. So what they are trying to say is you can't use 3 and 3 once again. Like you can't return 0, 0 and say that 3 and 3 kind of sum up to the target. That's something invalid. However, you can send 0 and 1 index irrespective of what their value is. So they really don't care about what value it points to, but it needs to be a unique number. That's kind of the sole criteria here. And then this is why we are actually pushing this index into and the number into our hash set, because it is highly possible that in future you might encounter a number that is actually this complement. So let's do a dry run for this first example. You are you are holding 2 in your hand and you're just checking like, is there anything present which is an n complement to this current number n? No, right? Like n complement is empty. So you directly push it with the index. So 2, you create a key. So if I were to actually give you a dry run, let's write it like this. So you create 2 key and you put 0 here. Then you go to 7. Like you'll ask this question, like 7 is in my hand. I know I need to add 2 numbers to give to the target. I know the target and I know like I can keep track of all the n complements that I've seen. So you just look for this number, like is target minus n, which basically means have we seen a complement to this current number in our hash set? So to repeat, have we seen complement of this current number in the n complement dictionary? If this is the case, you have the answer, and which exactly happens in this case. You'll check, is target, which is 9 minus 7, is 9 minus 7, which is 2, is 2 in our n complement? Yeah, it's there. So then you simply return that and you have the answer. And the reason why I'm not returning none or anything here is because they've told that you have one valid answer. So this is another case why we actually return immediately after finding an answer, because they have told that there's legit one answer. So there's no point in actually going forward and looking, because you will just exhaust all the numbers in your nums list. And only to realize that you've already found an answer. But if the question was different, where they might ask you, send me a list of indices, or like give me all the pairs of numbers that kind of sum up to the target, then this return is not valid, and you would actually push things in an output list and then keep track and then return a list. And then talking in terms of follow-up, we have already like discussed this in extreme detail. So I hope everybody is expert. And like, again, to summarize, if let me quickly run this first, just to see if this is yeah, okay, this is fine. Okay, this passed the test cases. So to summarize, please don't feel disheartened if you weren't able to solve this question for the first time, and don't beat yourself up by saying that, hey, this is easy, I should solve. No, that's completely fine. The main reason here why I think is this kind of categorized to be in medium is because this demands this kind of mathematical thinking. So it actually has gotten nothing to do with your data structures and algorithms thinking. I mean, obviously you need to know how to use a Hashmap or how to actually properly enumerate through these indices, but I feel like it has gotten some mathematical flavor to it. And please don't feel disheartened, and just keep repeating these things once again. So thank you for watching this video, and if in case you have anything specific or any question that you would like me to solve first, please let me know into the comments below. And on another note, I'm actually thinking of creating animations, so if that is of interest to you, please let me know in the comments below. Thank you for watching.